into life-enhancing tech. Team members and roles: Matthew Birch, project manager, researcher, developer, and documenter. Sophia Carmichael, researcher and documenter. Alan Thomas, system modeler and researcher. Gani Adebayo, system modeler and researcher. Myself, researcher, presentation. The aims and objectives: selection and application of a project management methodology to structure the project. Thoroughly research the market in order to establish a unique life-enhancing product. Undertake market research to gauge the views of the target population and determine whether our concept is suitable. Analysis of market research to determine the feasibility and usefulness of the proposed concept. Define and generate the requirements for the proposed system. Implement prototypes using an appropriate software development methodology. Test designs with users to develop the prototype. Deliver the final prototype.
So, as project manager, I led the project. We followed the 5 phases of project management, which are initiation, planning, execution, control, and closure. To do this, we used a work breakdown structure. So we had each of the different phases, and in them phases I outlined the tasks that we needed to complete. And then we took them tasks and placed them into a Gantt chart and used timescales in order to know how long it would take to complete each task. We then used different means of communication. So WhatsApp was the means of communication in terms of booking meetings and that sort of stuff. And then Google Drive was the means of communication in terms of sharing documents and having sort of a workflow that was in sync and very communicative. So the methodology in which we used was Agile, more specifically Scrum. What we did was have weekly sprints, and we used sprint planning meetings to outline what tasks that we would cover within the week, and then we had Scrum meetings throughout the week to understand where we were with tasks and if we needed to hurry up with the completion of tasks or place different members on different tasks so that they were able to complete the task within the time given. So to do this, we documented the sprint planning meetings, and that was where we'd outline each task that we wanted to complete within the week, and then we'd also log each of the respective meetings and their timescales to understand if there was anything that we needed to go over again as a team to make sure that we were completing the tasks within the time frame assigned to it. So what we did as a team, we mapped out different concepts that we thought we could carry out and run with within the project. So I came up with 2 ideas, and so did Alan. My 2 were smart storage and energy reduction. The idea of smart storage is that within the home, it can be very difficult to keep track of the items that you place into storage. So therefore, the idea of smart storage is to have a storage system that is able to smartly control how you store products in order to know their placement within different storage compartments within the home. And then energy reduction was just a basic concept in that as you enter the household or enter different rooms within the house, different energy resources mechanisms would turn on, so things like lights. So if you entered the home and then it would sense that your presence is there, so you could switch on lights and heatings to make sure the house is controlled smartly. But that can extend to TVs and different electrical devices as well. So you can charge your phones without being in the home, or you can switch off the TV as you leave the room rather than having to do this physically. Is that?
So this is the concept brainstorming phase. So during the start of the project, I came up with 2 ideas. One of them was AB Celsius, and this basically revolved around a monitoring device which regulates temperature, and it works with an app that would be with the user. So the user can input temperatures, and the monitor could communicate with the app, and it will create an optimum temperature. And this can be very user-centered as well, as the user can input their own temperatures, and for example, if they're feeling ill, the regulator can put a temperature that can be both comfortable and useful for the user. And the next idea was the EBD, the Essential Beacon Device, and this idea came to the forefront after Tarek brought about the whole refugee topic. And this is basically, at the basic, 2 Raspberry Pis, where one Raspberry Pi is the transmitter Pi and one is the receiver Pi. And the transmitter Pi is with the refugees, and both of them would be touch sensitive, and you can send commands from them for food, drink and medical supplies, and the receiver Pi, which is with the aid organization, and the workers can receive the command and appropriately send and distribute the aid. And this is centered around sustainable distribution and maintaining track of what is being used and who is being used for.
So the concept that we decided to run with was smart storage. We discussed this as a team, and then the overall consensus was that this idea was feasible within the time frame given. Therefore, this is a concept that we thought we would build upon and see how far we could take it. So within its current context, the way in which we store products is done cognitively. So therefore, there's many drawbacks that this way of storing products can bring about. So there's different ones. So forgetting where products have been stored. So if you bring an item into the home, you place it within storage, it's very easy to forget where you've placed that product. And therefore, by having some sort of mechanism to remotely view what is in your storage compartments would save a lot of time and money and resources. And then the next one is limited access to products. So if you, in its current context, you can only view what's in your storage compartments actually physically being there, whereas the idea that we're proposing, you'd be able to remotely view what is inside your storage compartments in terms of the products. And that links directly to over-purchasing. So say if you're in the supermarket and you're buying products, you could over-purchase because you don't know what's already in your storage compartment. So that's the idea there. So our proposed concept intends to remove the difficulties found within the current context in the way in which we store products within the home. I'm going to walk through the system and how we have decided that it would be implemented. So you have your user, and the user will configure the physical storage compartment using the app. So they'll take the dimensions of the storage compartment and then within the physical storage compartment, and then within the app they would specify the volume of that compartment, and therefore you would have a virtual storage which would model the physical storage. And from this, our products would need to have a QR code that would sit on the products, and then they would be scanned in to the storage compartment using some sort of scanning mechanism. And from this, the item would then be scanned into storage, and then the virtual storage would reflect that state of the physical storage. And then they can then access the app in which the virtual storage reflects the physical storage, and they can remotely view the contents of that storage compartment and know the details in terms of how full that storage compartment is, how many items are in the storage compartment, what sort of items are in the storage compartment, and so on and so forth.
In order to gain a thorough understanding of where our product would sit when taken to market, we had to establish a detailed marketing strategy. First and foremost, we looked at the competitors who currently in the market and what products they had to offer in order to establish a unique selling point. So we looked at the Samsung refrigerator hub, which worked on a similar concept, and looked at how we could develop our own unique selling point. So we looked at the previous concept as mentioned, and then looked at how we could develop smart storage in a unique way which would entice our intended market. We then looked at how we could what sales strategy we would use to entice users to purchase the product. So we looked at 2 different forms of marketing, both offline and online, and the different prospects that they could both bring. So for instance, with offline, we looked at in-store demonstrations, enabling users to actually experience the product for themselves and engage with us. And we also looked at online strategies, so social media, search engines, and then working through the sales cycle from cold prospects to hot prospects, which bring sales of the product. We then looked at who the actual target market was through profiling of the audience. So that was domestic occupants to begin with on a small scale development level, and with broader scoping we could introduce a larger market. And with regards to domestic occupants, we looked at why they would purchase a product. So, for example, to keep track of their groceries and their shopping list. We could internationalise this further once the product had been established and developed successfully. Once the target market had been profiled in great detail, we then created a survey and an accompanying participation letter to inform a specified strata, which is basically 2 separate groups of users. In this instance, we chose the domestic occupants, and we chose 5 from each group, so the under 25 and over 25 category. So in the survey, we asked different aspects of usability and feasibility to determine whether the users would benefit from using this product. Once the data had been obtained, we then coded the answers and implemented them into Excel so that the results could be filtered as displayed on the screen.
So from the walkthrough that I demonstrated earlier, we have both hardware, middleware and software aspects. We decided as a team that we would focus solely on the accompanying application. This was due to the time variant that we were given for the project. In this section we have created a requirements breakdown, and therefore we just sort of specified what we wanted within the product. So we have different pages or different interfaces. We have a user authentication page. This is a security measure so that people from outside your home can't access the app and see what's in your storage compartment. They would have to log in or have some sort of means of authentication. We then have our storage setup interface, so that is where you take the physical measurements of the storage compartment and then specify them within the app, and that will then create your virtual storage space, which will model your physical storage space. We then have our transactions option interface, in which you will take a physical product and you'll scan that item through the scanning interface and into the storage compartment. This would be reflected within the virtual system, and it will detail what items have been scanned and placed into your storage compartment.
Okay, so this was basically the system modeling phase, and this required me to build UML diagrams, and one of the first that I built was the use case diagram. So what this diagram basically emphasizes on is the user who interacts with the system, and the user or the subsystem that interacts with the system, which is the smart storage app, becomes an actor. So whatever functionality that the actor communicates with becomes the actual use case in itself. So for example, we have the user here who could be the aid worker or the standard user, and they would communicate with the functionality of the app, which one would be scan product, and therefore that becomes the functionality within the encoded system. And for some, you need actually both actors, like the user and the notification system, for example, because if the user enables a system where you want to get notifications on expiry dates, for example, it needs to be appropriately specified by the notification system. So they both work together and it's more harmonious, for example. And this can easily be translated for the programmer, as they basically gain the fundamental understanding and archetypes of the programming fundamentals, and they can easily translate it to the software code. And in junction to the use case, I also had to do the documentation for each and every specific functionality that was included within the smart storage system, which also helps the programmer in one way, as you list down ID, description, preconditions, postconditions, the flow of events of how the functionality happens, and alternate courses that the use case or functionality can go in. Now, class diagram was one of the most important phases in the UML diagram processing, because this basically gives you the static view of the application, as it gives you the class names, its associated attributes and operations. So for programmers, this is the easiest diagram to map to an object-oriented program like Java, C++, Python, etc. And for example, we have the user class with its appropriate attributes such as user ID, username, password, and their associated variable inputs such as integer, string, and then we have the operations listed out as such as input login details, scan product, create product folder, etc. And the most important thing with the class diagram is how you list the classes with their appropriate relationships and their many-to-one attributes. So we have the user and aid worker and regular customer. So these two classes are basically inheriting from the user class. So as in, these two classes inherit both their attributes and operations to use in the actual software. So it becomes easier for the programmer in one way to build and structure the software code, and it takes a lot of workload off them basically.
This diagram represents the sequence diagram. The sequence diagram represents the sequence in which objects passes messages to each other for one use case. The sequence diagram models the way in which the system is being used. The sequence diagram shown represents the registration sequence diagram. The user here represents the actor where the interface manages the dialogue between the user and the system. From here, the user attempts to log in, and then the database checks the user status, that is, if the user already logged in, has an account, or if the user doesn't have an account. The database verifies that the user has an account, and then the login is successful. If the user doesn't have an account, the user then needs registration. The user then requests the registration page. The database sends a registration page back, and then the interface displays the registration field. The user enters the user details such as name, password, date of birth. Then the user then clicks the submit button, and then the interface sends the new user details to the database. The database then verifies the new user details. If the details are wrong, the database then sends it back to the interface to show that the details are invalid, and then it sends an error back to the user. Then the user then re-enters the details. If the details are correct, the database validates the new user, and then it saves the account. If all that is done, the an acceptance email is sent to the user. A sequence diagram models the way in which a system is being used. It explores the logic of system methods and the logic of services.
So because we're targeting our product towards domestic occupants, we are looking to integrate this technology within the home environment. Therefore, a user-centered design approach is very key to understanding whether users can actually use our product. Because our demographic is so large, we're looking at all different age ranges, all different people, and therefore the user-centered design process would determine whether groups of all ages are able to use our system. Scrum was used with our user-centered design approach to manage the iterative development. So you'd have sprint planning meetings and Scrum meetings within the user-centered design process. So you'd create low-fidelity prototypes, and then you test them with users, and then you'd create another requirements breakdown. And this is going through iterations to enable the product to become more user-centered and more user-focused, and that would enable our product to thrive further within the market that we're targeting. So in order to ground our concept further, we developed low-fidelity prototypes. These were just quick mock-ups on paper, and they were just to detail the different types of features and navigational components that we would have in our application. The idea of you doing this is that we would take this design and test it against users after putting it within POP, which is paper prototyping application, in which you can create navigational links between paper designs, and then that shows how the proposed system would work in terms of front-end development. By doing this, there was no sort of commitment to the design. It could be changed, it could be adapted, and there was no real major effort that was put into it. So then we could change the design to fit it around users more, to create a more usable design. These were the initial prototypes that we developed on paper. So this outlines the login screen, this outlines the sign-up screen. This was part of our security measures. This interface outlines the main screen in which you will be able to create your storage compartment through use of this form, and where you specify the storage ID, the capacity, and the description. From this, you'll be able to model physical storage virtually. From filling out that form, that would then create a new storage compartment, and within that storage compartment, it would specify details like the ID, so which storage compartment it is within your home, and also the space remaining, so how many products are left within storage, and how much percentage of space is left within that storage compartment. This then details the scan new screen, in which you scan products into the storage compartment so that they are reflected virtually. To do that, we would use a scanning mechanism, so it would be a QR code scanner, and that would scan the product, the QR code on the product into storage, and then we would specify by different attributes, so product ID, product name, expiry date and volume. We specify the different specifics of the product. After creating our lo-fi prototype, we tested our products with users for our demographic. That was our target market within the age range below 25. This is known as a strata in that it's a specific part of the demographic as a whole. We focused on the age range lower than 25 because this was more specific, and it gave us more specific results about what we were testing in terms of the strata or the users. The feedback from these tests was quite useful in that it gave us an indication of where our application was misunderstood, or processes within the application were misunderstood. And therefore, we were able to sort of shape our design better towards users after understanding the different flaws within the system. The general consensus was that the design was difficult to understand, and that it didn't have enough feedback in order for the users to sort of understand where they were situated within each interface. So therefore, we needed to sort of remove the ambiguity to sort of make the design easier to interpret. Based off of the requirements that we devised within the previous section based on our user testing, we came up with a mid-fi prototype design, and this design was to remove the flaws that were evident within the previous design to improve the design for our demographic or target audience. From doing this, we were intending to enhance our design in terms of efficiency and effectiveness, so that it would be more usable within the environment that it was specifically designed for, which is the home. So from the requirements breakdown and the intro to the mid-fi, these are the designs that we came up with. So as you can see, the buttons are improved. They are close to industry standard buttons in that they are very recognisable. They have the outline, they have the text inside. They're very recognisable as buttons. So this shows the login and sign up page. Within this add new storage compartment, there was more clarity provided, because originally we just had the add symbol, but it would seem that a lot of users sort of struggled to grasp the concepts of just having an add symbol and creating something. They wanted something more feedback. So we included add new storage as the caption, so that they would be able to understand what this process is doing and what it includes. This then takes them to the create new storage form, in which buttons again are improved in terms of clarity, as well as understanding where the user is situated. When the storage space is created, we have included an open button, so that it is very clear that this can be in fact accessed, rather than just be a banner or some sort of declaration. When opening this storage, you then moved across to the scan new page, and here this page remains quite similar to as it was within the lo-fi design, because we felt that from this page there was no difficulties when using the system. The item is then scanned through using the QR code scanner, and then the item would then appear within the storage space. Space remaining indicates how much space is remaining within that storage compartment, and all the different attributes concerning the product are then captured and stored within the system. From the original lo-fi design, parts of the system were missing. This was because we wanted to create a design that was unitized so that more features of the system could be included at later iterations to understand, so that the testing was more specific to an individual task. Therefore, we could expand upon the components within the system at a later date to introduce new aspects of the design to users and test them specifically as a small unit. The scan new page, once removing the item, select remove item, and you can select the item that's placed within your storage compartment. When removing the item, the space will then return back to its original state, and the item will be removed from storage. When conducting the user evaluation at mid-fi level, there was great difference between how users perceived the low-fi compared to the mid-fi, and there was improvements, especially within efficiency. And the average of 43 seconds in terms of completion time within the mid-fi was far better than the low-fi that was 1 minute 6 seconds. Therefore, we can see a statistically significant improvement in terms of efficiency between the two designs. This shows that the functional aspects of the design, so efficiency, effectiveness, are being improved across the iterations. However, the aesthetical aspects of the design were questionable in that users couldn't understand all of the content that was placed within the application. So the qualitative feedback that we received from users suggested that parts of components within the application were difficult to interpret and understand. So from this, specifically the home screen, a lot of users suggested that the content that was placed on the home screen was difficult to understand because it was a light blue with white text. So in order to improve this, we would change the colours of the login sign up page so that they don't clash, and so that users, to allow for improved readability. Extra feedback could also be implemented within the design so that it would be more informed towards our demographic, and they would understand the different parts of the design better and where they are within the interface and how they interact with different components.
The product in its current state is undefined as it doesn't cover the hardware aspects of it, so prototypes would need to be further developed to resemble the scanning interface mechanism on the storage compartment to better demonstrate the componentization of it. Resource management would be a key element in producing this part of the prototype. So that would involve better resourcing, so in terms of financially producing the hardware component. With regards to the target market, this could be broadened to cover internationalization and different instances such as aid organizations to help humanitarian crises, and also aid individuals who may suffer with mental health issues where they may not remember where they store certain items, and this smart storage device could help them to keep track of where items are stored. But that would require further development to cater for these kind of problems, given more time and more resources.